Good morning, Fritz.
Hey, Mark.
Hey,
Are
welcome.
you in the US? You say good morning. I thought you were somewhere in
Uh,
Europe.
no, I'm in Seattle.
Ah, I see. So it's the
Oh,
6 a.m. meeting for you.
near Seattle. Oh yeah, yeah.
Great.
It's usually not even my first meeting of the day because I work with everything from, Singapore to Hyderabad. So.
Oh, no. Okay. No, I'm happy
Hugely
when my 7 a.m.
multinational.
meetings are rare.
Oh yeah, I would much rather have a 7 a.m. than 7 p.m. meeting for sure. But
Yeah,
to each his own, I
that's
suppose.
that's true as well.
Sal, hi.
Hello.
Hey, so.
I thought you were done with our ragtag crew now.
Yes, but I'm very far from being done with workload identity, and I have to give a talk on it on next Tuesday. So I'm going to check in on.
Really? Where is the talk at?
There's a whole half day dedicated to workload identity, Spiffy Spire style.
Oh, okay.
Yeah, in
Is
London.
Peter Castleman going to be there?
I don't think they're not giving a
Oh,
talk, but they might be
oh,
present.
I
Um,
see. He and I
yeah,
talk offline. Well, outside of these meetings, trying to figure out how to put the square peg in the round hole there. Okay, well, cool. So I hope you get something out of this meeting. Um,
thank
we're
you.
just going to give a couple more minutes for people to file in because we have a boatload of work today, and I just want to make sure we don't leave anyone behind.
Yeah, and I believe we're still dealing with the time change issues in March. A bunch of people have been missing from the US, so we'll see.
When does the Europe switch over?
I think on the 28th, so this is the
Oh,
last week
Jesus Christ.
of
Okay.
chaos.
So Deshna, hi, you're new. I don't recognize you.
Yeah, I'm
Hi, I'm
bringing some NVIDIA.
resisting.
Go ahead. Sorry.
Poetry.
I'm bringing some NVIDIA people. That's why I'm joining the first half. Um, so feel free to introduce yourself. I just wanted to give context that you're also joining from our side. Go ahead.
Sure. Hi, I'm Sudeshna. I'm working on the CC solutions in NVIDIA, and I'm part of the CUDA driver team, trying to bring up CUDA toolkit and runtime on the CC products we have.
Fantastic.
Welcome.
Yeah, as a side note, you might be interested in that, Deshna, because you're at NVIDIA. The protocol I'm looking at to see how it fits with all of this is VirtIOFS, because I want to understand how you put uh, make workload identity work with that. And I know because of extremely high throughput on GPUs, they're now doing all sorts of interesting things there, like RAID controllers. And uh, so, so whenever you deal with file systems, you need to make sure that there's the end-to-end protection. And it's at block level, it's pretty trivial. But once you get into file level, to figure that out. So anyway, that's a side note. I literally just opened the documents today to familiarize myself. All right, so it's at 6:04. So we're going to have whoever joins will have to catch up at this point and maybe watch the recording. So what I'm going to do is I'm going to bring over to the screen my document here. Just give me a second. All right. So, identity requirement. All right, so just to level set, we finished our charter, and that was an interesting process. And in the charter, we basically said there are three core requirements to calling a workload identity trustworthy, and that was workload isolation was one. The binding of credentials to the workload instance is the other, and provenance, being able to establish what decisions led to the issuance of the workload credential would be third. So while those are requirements, they are basically incorporated by reference into the this requirements document that I'm going to share now. And please confirm that you can see my screen.
Can see it now.
Okay, great.
Can
So,
you
and
put a
as
quick link
usual,
into the
I'm going
chat
to
for that,
drop. Sorry?
please? Can you
Yeah,
just throw that into the
I'm gonna drop the link to the chat. This is the document we're looking at, so you can open it locally. And I'm watching my request for a sharing over here. So if you need it, then I should be able to share it expediently. Okay. So what I would like to do today, this started as a document I wrote for the consortium to convince them that we need to pay attention to workload identity. So it's effectively all my words. This is not our words just yet, and this is the next step. So it became an MD file in the attestation SIG GitHub. And I don't really believe that most of it belongs in the attestation SIG, although we'll talk about some of that later. I basically took that document, brought it over here into our Google Docs folder, made a few edits, but like primarily removing duplication with the charter. And I would like to basically go down the list here and start the discussion of the requirements as written. So we can, at this point, suggest changes and or basically say, okay, we're okay so far. And then the next check, after we go through the list of requirements, it's more of a completeness check. Have we covered all the things that workload identity must be expected to accomplish? So let's go down this list. So you can read along, but we're basically the first requirement is portability and based on standards. So we're not doing anything bespoke. Specifically, when I presented basically our core requirements of the charter at the Whimsy IETF meeting, the very key promise that I made there was that we're going to become compatible with Whimsy. And hopefully compatibility there means, oh, I see the share request. Okay. The compatibility basically means that, majority of what they're doing shouldn't change. But, with luck, it's going to be nothing, but I think it's going to be just maybe a little something that needs to change. So for instance, provenance is not in the Whimsy standard right now. So we will need to figure out how to, accomplish that. Okay. So, yeah, so please, if you requested access, you should have it. So, again, I am not mentioning Spiffy or Whimsy here, but we're basically saying we need to be compatible with standards that are out there. We're not inventing new standards. The second one is about environments. So on premises, cloud, personal devices, or remotely managed IoT devices. So it's an expansive list. We may need to prioritize it somehow. And again, feel free to speak up and interrupt and add your ideas at any point in time. I'm just sort of going over it. If I don't hear anything from you, then I'm assuming that there is no
So
contention. Yeah.
I can't speak in detail for the stands that the other folks had. I expect them to join later or either next time. But one concern that we had in internal discussions was a little bit that, and to speak a little bit to the point of aligning with the other specifications.
Yes.
That redefining things like trustworthiness or trust feels like a moot point if we can follow RUT's definitions and can follow these things. So I did not have the feeling that you really want to come up with kind of your new definitions. But just to kind of mention that point again, because
Well, so can you be a little bit more specific? So what is this about?
So I see it's not actually not in this document. Maybe I was wrong there. In the governance repo, in the governance document on the request for becoming a SIG, there were some sentences on like defining trustworthiness, etc. Just to kind of confirm that we are on the same page there. These were in there just for the reader and not for coming up with new specifications or new definitions that work alongside these specifications, right?
So okay, so I don't know if I'm answering your question, but I will try.
Mhm.
The goal is broad alignment, but on occasion you will see that there needs to be a small tweak. So for instance, Whimsy defines a workload in a particular way, right? So it's some software deployed for a particular purpose. Like you can read their definition. And in this working group, we basically said workload is as defined by Whimsy, except in addition, the workload is basically required to be remotely testable. So, for instance, if you have a workload that does not have something that is attested, well, that we cannot speak to the identity of that. Right. So, for instance, if you have a virtual machine hosting an enclave, the enclave will have that will be able to get a workload identity, but the virtual machine around it, unless it's a confidential virtual machine, will not. All right. So that was, but it takes the workload definition and constrains it a little bit. But this is a necessary constraint because otherwise, you're not going to be able to, speak to it from the point of view of confidential computing. So we have to, on occasion take a small pivot. But I believe it's containable within the broader ecosystem, because if you don't want to test it, well, that this is not a trustworthy workload identity, do your own thing. That's fine. Right. So we're broadly keeping the definitions, even though there's a deviation, we carefully document. So
okay, I think then we're on the same page. I just wanted to double check that.
Yeah, and
we're
if
not
there
here
is
to come
a
up with new
glaring
things,
discrepancy, then we need to close it. Like if
Yeah,
there was
yeah,
something
exactly.
that was missing, then yeah. So the goal is to stay as close as the laws of physics allow. Okay. All right.
And go ahead.
Yeah, hi. I have a follow-up question there. So just stepping back, so confidential compute has been focusing on hardware-based trusted execution environments, right? So in the context of this TWI definition, I wanted to clarify, like for example, in the up there in the first paragraph of the document on requirements, we have stated that controlling which workloads can access what data, right? So the access control to data is, it starts from the hardware TE definition in many ways, right? So just trying to
What do you
understand
mean?
better
Sorry,
the
well, let's
chart.
go back. What do you mean by that statement? The access control starts with hardware.
I mean, the basis for confidential compute is a hardware-based TE. So how you define the boundaries of the TE also set expectations for access controls, right? At the very
And that's
bottom
where
of
we
the
say is
architecture.
your workload is bounded by what can be remotely attested, right? So in the charter, we say that. If you would like me to, I can pull up the document and show you. But so in the charter, which is now a pull request, specifically we say workload as used in this document restricts the definition of the same term by Whimsy, which is a running instance of software executing for a specific purpose, to just that part of the code and configuration of the workload that is subject to remote attestation. Right.
Okay.
So that
go ahead.
So and I basically what I'm trying to do without explicitly saying it is and this is kind of deliberate on my part. We have approximations of confidential computing out there in the world that are like from people who are not even parts of the consortium, like AWS with Nitro, which is not strictly speaking confidential computing, but there is still attestation in there, and you still be able to make the standards that we're looking to develop work with that, right? So there is not a desire here to go so restrictive as to say, well, because AWS is not the Puritan version of confidential computing, that we're just like not going, like, to the best of our ability, we will work with them.
Thank you. That
Access.
that does explain it a bit, and thanks for clarifying that.
Okay, hold on. Is there any other requests for access? Just let me double check. No, not anymore. Okay. All right. So the third one. So the second one is where it can get deployed. If I miss something, I tried to cover all bases. But we can always add if you come up with something. All right. Now the shapes of the workload. Here I'm basically saying confidential virtual machines, containers, and Kubernetes pods. Maybe I should say confidential containers. I don't know. You tell me. Enclaves, or and like, why did I bother to say confidential virtual machines and not just virtual machines? I don't know. That's why I'm like, I want to stay consistent. Enclaves, everyone knows what that is. Serverless computing, so Lambda stem functions, etc. So these are the things that are generally short-lived ephemeral workloads that are not containers, not virtual machines. You have no idea where they run other than they get invoked somewhere. And also need identities, of course. They need confidentiality protections. Right, so then there are just basically all the services, queuing services, database services, whatever you may want to stand up in the cloud. So you stand up, some sort of database, and AWS Redshift, if you include AWS, or maybe you stand up Nginx somewhere in Azure. If you want to run it in a confidential, in a T, well, that becomes a type of workload you need to give an identity to. And then managed services are different because you don't instantiate them. You work with a SaaS vendor, and there is some sort of, again, managed service included here, vendor service that, like, you might use Wiz, or you might use, Snowflake for whatever, Databricks, etc. So again, if this is not a complete list, or if there's something that doesn't belong on this list, we can talk about that. All right, number 4. This is where it starts getting a little bit interesting. This is where we talk about lifetime. Sorry, we're actually right. We're talking about the fact, and this is I think it's Dion from Google mentioned that, like, can workloads nest? This was part of the charter definition, and I moved that into here. But you can have a standalone workload, or your workload may be composed of smaller sub-workloads. And here I make a statement that the components of a larger workload share the same lifetime. And I don't know if I believe that. Like, that's why I kind of put this here as a notion. We don't need to resolve it today, but it's kind of a question to mull. Do we, in case we have a composite workload that has an identity, like if somebody takes a robot and removes like a part and reattaches another part, is it the same robot? Like, I don't know. Maybe not. So, and they're here basically saying your workload may be spanning devices or having components and residing in the physical device. So I'm basically trying to incorporate two sorts of things here. One type of workload might be several containers in a pod. Another type of workload might be something that some of it runs on the CPU and somebody runs on the GPU, and some of the same workload runs on the smart NIC, and they all need to communicate with each other. But another one might be that the workload is, kind of a larger thing that, means inside of it has like some sort of cloud service that has, compute units and queuing units and lambdas, but from the outside it looks just one thing because you don't know its internal composition. Only that as an entity, as a composite entity, you trust it. So this may be maybe need an illustration, but here we're basically saying your workload might be standalone, or you may decompose it into smaller things, and those things may have identical, may have.
So I have one comment, because you
Yeah.
asked in the there's a comment there if lifetime or timing is correct and a good way to phrase it. I wouldn't call it lifetime or timing, because it's not true anyway on a like cycle accurate basis, right? So there will be different lifetime for the GPU workload than for the CPU workload. It will be off by at minimum a few cycles, right? So lifetime is already, depending on how granular you want to speak, not the same.
Well, this is where I say from deployment to decommissioning. So
yes. So what I was just trying to get at is, I think context might be the better phrasing to name it, right? Because even like even that taken aside, you might not have the same lifetime, right? You might decommission your GPU workloads and then start up a SmartNIC workload. Probably not the case, but you could, which would mean that you have not a consistent lifetime throughout all three components, but your trusted computing base does span across all three, right? So
yeah,
I would call it rather context and wouldn't pinpoint too much on lifetime, because it might not be the same lifetime.
yeah, I hear you. I totally hear you there. It's you know, this is sort of why I called it out, but a couple of comments though. Context we have to be careful with, because Whimsy defines context, and it's something entirely different. There's like a context service in Whimsy architecture. So whatever term we pick for what you're saying, should not be confusing from the sort of the broader perspective. And the other thing that begs into question. So say I have a workload that part is runs on CPU and part runs on GPU, and then say the GPU, portion went away, and then another GPU workload started, but it's a different one. Okay, are we now talking about the same workload identity or a different workload identity? And I don't necessarily have an answer to that, but I guess the notion I'm trying to encapsulate here is whatever happens inside that composite workload, maybe even if we granted that the components may shape shift, may come and go, maybe lifetime isn't the right thing to name it, it's still in a way identity preserving. So again, I don't know how exactly to phrase it, and we may need to wordsmith this somehow. So
I agree, and I didn't also mean to like now start a semantic discussion here, right? So I think like we both equally don't care that much about what exactly the final like statement will be called. Like I'm just trying to say that I wouldn't bind it to time, because it feels like that what components you have in there during that lifetime, like during the lifetime of the workload, let's say, matters more than that all of these components shared this lifetime, right? So if I only quickly spin up a SmartNIC to do some networking and then destroy it again, this might still be all across the same workload. I'm not like it doesn't make sense to me to split that into 3 workloads before, during, and after SmartNIC was involved. Right?
You are correct. So that's what I'm saying. I'm going to add an issue. We should have an issue section down here that we like basically things that we call out. This is going to be important to discuss, right? So how about we'll track this as an issue at the end of the document.
Totally fine.
Okay.
Yeah.
So let's do that.
Now also actually have to drop now.
Okay.
I'll try to ping some more NVIDIA folks and make sure we join the next calls. Just to ask about timing, so is there some leeway in moving this around if this is a bad timing for some NVIDIA folks? I don't want to move this if it works for all of the other companies that have been joining, but just to get some more traction.
The timing isn't entirely up to me. So it's we've did a poll. We asked a bunch of people what
You
time
already did, Paul.
works.
Okay, I just
This
wanted
is
to check that. Okay,
yeah, and I'm not averse to having it moved, but like all of us have corporate jobs and other conflicting meetings, etc. So you
Yeah,
know
all
it can be challenging, but you know, if push come to shove and we must, you know, we'll definitely consider it.
Okay, no worries. Okay, I'll see, and then I'll try to find the recordings afterwards and then try to send it around. Okay, thanks, folks. Bye bye.
Mhm. Okay, so I just added the issue. We'll call it issue 1. Okay. Oh, I'm coming up with notation in real time here. And you're correct, Sal. The agentic AIs are.
Yeah, I
I have
think,
no idea. I have no idea how to deal with them just yet.
yeah, so I think one of the things that's pretty serious and interesting about the Spiffy Spire stuff is that it allows us to do sort of time-based like threat protection.
Mhm.
So that might be, I think if we can get the wording on that more correct, excluding the dimension of time and not using life cycle. But I think it's something that we could bring up
Yeah.
more insight.
I'm like literally studying philosophy of ethics right now to understand how to manage responsibilities around. Yeah, I'm not prepared to talk about it yet. It's way bigger than my brain right now. All right, so moving on to issue number 5. And by the way, I'm going to stay past the top of the hour for the next hour for people who may have gotten confused by the time zone again. So I may have to go through this again in the next hour. So we'll see how much more information we can or input we can collect. All right, workload may have multiple distinct credentials issued to it. So this is basically in keeping with Whimsy. Whimsy does the same thing, basically saying you can have workload to workload, identities. You may have an identity that you present when you talk to an external party. So this is where I'm basically saying your identity may be different for purposes of inbound. Somebody perceives you to be workload A when they talk to you from the outside, but when you go and talk to some backend service, your workload B, and then the bits and pieces that compose your workload when they talk to each other may have different identities still that are not even necessarily presentable to the outside. Maybe it's internal trust domain. So, and the question here, and this is where Sudesh, you may want to chime in. It is not on its face clear to me that when CPU wants to talk to GPU over something like TDISP, that it's going to be the same workload identity protocols, that they're in the same kind of handshake necessary. Maybe it's something completely like different mechanism for how they authenticate each other and how they establish secure channel between themselves. So I'm not claiming that the same set of mechanisms is going to apply universally. Maybe there are carve-outs for things that happen on a given device between components of the device. But it would be really nice to get your guys' perspective on how you see this. All
Sure.
right.
This is an interesting question, and I'll make sure I take it to the right experts there. Right
Yeah.
now, there is a form of device attestation, and you're right that TDISP will have to, we'll have to accommodate TDISP within that as well. But one thing that I'd like to understand about this particular point is does this apply to hierarchically spawned workloads? Is that what you're thinking about with internal workloads here for composite
Right. So if
workloads?
you read the Whimsy architecture, they talk about it. So that's sort of the best way to understand it is if your workload contains multiple internal components, then these components may also need to talk to each other. And they may have identities suitable for that. So that's why I'm saying that
Right.
you're
At least
right.
TDISP does define the concept of a set of states, right? So it begins with a state and it ends the secure session with another state. And during that time duration, the TDISP state machine is supposed to track the established ownerships and identities that have been contractually exchanged, right, between the host and the and the device security manager. So, like, I'm just trying to imagine here, and I'm thinking
Right.
about this for the first time, so maybe
Yeah.
thoughts are not clear yet. But
Right.
like,
So it is not necessarily clear to me that so the same sort of workload identity standard, like if we were to become whimsy compatible, would also apply to something like TDISP. They may be entirely different mechanisms we may need to look into. Maybe there's commonality enough to factor out, or maybe we'll just treat them as entirely different. So this is still early days, and this is such a big area that these are the sorts of things that we will need to discuss, and we don't need to decide them today. Right now, I'm basically
sure.
saying, look, at this level of refinement, your workload may have inbound identity, outbound identity, some sort of internal, component to component identities, and then we'll have to figure out from here what happens in all of these cases. And this, we'll need to formulate our requirements, and then we'll need to go and address all of these requirements in the reference architecture, which is the next step. All right, so this was about the sync credentials. Requirement number 6 is about lifetimes. So if you try to do full credential issuance to every ephemeral workload in your enterprise, like every Lambda, every step function, every pod that might be spun up, you will quickly overload and bring down your verifier and your IDP. It's not going to scale. Right. So when we go into the reference architecture, I propose a mechanism where a workload can be started in provisioning mode, obtain some credentials, and seal them to the platform. And then from there, in the operational mode, where workload starts, it unseals the credentials it received during provisioning and starts using that without touching, without contacting anyone. And then if that credential is somehow expired, then okay, then it needs to get re-provisioned, and we'll work through that flow chart. Maybe there are other solutions to this that I am not thinking about, but those are the types of things that will not be in the requirements. They'll be in the reference architecture. Right now, I just want to highlight the thing that we have a requirement to deal with the thing. How we deal with it. This is not a, what's the problem? This is the what document. How would be the reference architecture. So again, that's the lifetime requirement. The next one will be the governance requirement. So here, I'm making a couple of statements, and again, that will probably get rewarded. Here, I'm just saying control over history of policies and decisions. Ability to identify remedy vulnerable workloads. Maybe this is not a complete list. I don't know. And then I'm basically incorporating whatever we end up doing in the governance SIG around workload identity, which we haven't even started yet. I'm just trying to incorporate that by reference. And we'll come back to this. I just wanted to say that workload identities are not just operational entities, they're also the governable entities, and we'll need to do something about that.
Sorry, Mark, can I go back to
Yeah.
point 6 once? So just thinking about the last clause there. In addition to system reliability, we may also want to provide a way to ensure that the workload context is reliably saved and retrievable, because like for really long running workloads, right, based on the current kind of AI stuff we have, like training use cases and all that, if there is a policy to revoke the credentials at certain intervals, then we would also like to make sure that the work done so far has been properly saved up. And I mean, I don't know how to interpret the trade-offs there, right? Like, what kind of a threshold would you build into that policy so that you could actually allow the credentials to last long enough for all the work done to be properly saved before you actually revoke and end the session?
I'm trying to see how to put this in words so we can track it as an issue. And how is it different for this? So let's forget confidential computing for a second. You have some long-running instance of software that's doing work, and at some point in time, and maybe it's continuously producing results, right? So that's how I understand the
Yes.
scenario you're
So
listing.
we have a whole area that we focus on related to checkpointing of such workloads, and it's a full stack solution in many cases, right? But
Yeah.
what I do not know is what kind of revoking policies we have currently in place. What is the standard that the industry is
Mhm.
demanding? I'm not an expert in that area, but
Yeah. Well, yeah, I never really thought about checkpointing, but let me put it this way: feel free to phrase this to the best way, to the best of your ability, and add an issue to the end of the document. We can do that asynchronously, so we don't need to dive into this just yet. But
sure.
I hear you. Okay,
Yeah, I
so
might be able to bring some insight from next Tuesday, but really the two main problems that I'm seeing, the scalability is something that nobody understands how to do well at enterprise yet, if we can give them examples, but particularly for number 7 here, it's the agentic AIs, which are the issue. So we need to be able to automatically identify and remove those.
remove what?
So automatically scale down workloads that pop out of or have the potential to pop out of their governance model. That is just the concern that I'm getting from interviews with people who are just starting out with workload identity, trusted workload identity. So it's not their level of understanding, something that we may just want to reference to. So a key example for this.
Okay. Well, these people you're talking to should probably join this working group.
Agreed. I'm going to point them to this on Tuesday.
Yeah. So that they can bring their concerns and we can, document them. Just again, right now, all we're doing is trying to, surface what requirements we have, because that's how we know we're solving the problem that matters. So yeah, bring them here. Let's have a conversation. And agentic AI may be as simple as you have ultra short-lived credentials that are for the duration of you performing a specific agentic function, and then if your nature of what your agent shifts, then the credentials are also different. So then that will have to maybe that can get folded under short-lived workload identity, which I already said you can provision once for a particular task and get those credentials when you need it for as long as you need them, without touching a verifier every single time, which would be bad, right? So, no. Thomas Sowell, there are no solutions, only trade-offs. So, same thing here. Okay. Now, this is maintenance operations such as workload migration. I do not know if I captured everything, but here I mentioned two things. If your operation changes the workload credentials, so some of the claims are now different, maybe you moved from your workload from Germany to Japan, then it's really a redeployment. So you get new credentials out of that. You bring down the workload, you start up a new workload, you need to get new credentials. Maybe you'll get different permissions, different access. Versus if you have a credential preserving operation. And again, I don't exactly know how to know that ahead of time, whether the operation is going to be preserving or not. Well, that is something we need to address in the reference architecture. But in that case, you should not need to get new workload credentials. You should be able to reuse the ones you got, or at least have an option. All right, and then reverse proxies. This is the one I put last. But it's going. So if you have traffic inspection, and then you have maybe for malicious payload detection, and then after that you have another gateway that perhaps filters out PII, and maybe you have another gateway after that that maybe inserts some additional context information into a request. So it may not be just one reverse proxy. It could be like several performing functions one after another. And then we'll need to figure out how does, if client A and server B talk across a number of proxies, what identities does everyone in that chain see? Right. So that's perhaps what I should put down here. If a client and a server talk over a series of reverse proxies, with some doing traffic inspection, others modifying the traffic, redacting content. I'm just putting my thoughts down. So we kind of need to know what's going on there. All right, so those are the 9 identified. None of this having to do with remote attestation yet. That's the next section. So quick check with both of you. Have I missed anything? Is there anything that is, like, I try to be comprehensive across these things, but maybe I have a blind spot. It would be nice now to know what that is.
I think this is strong. I think if we can also get some agreement across CCC on that lifetime definition or changing that language, I think that's going to get the right people involved because they're working on exactly this time-based threat model.
Who is they?
By they, I mean, so I think it would be interesting to bring in some of the like key end users of this, like Uber is using this, Square is using this, and I'm talking to those engineers next week. So
Mhm.
they have enterprise experience utilizing this.
Is that at
And
the KubeCon? Like, where is that?
No, so I'll put a link in the chat, but there's an entire day dedicated to workload identity on Tuesday in London.
In London. Is it remotely accessible? Can I?
I believe so. It's free registration. I'll throw a link in.
Yeah, okay, please. I can make an effort to join. Okay.
Okay, so I think just to add to what Frizz was mentioning when he brought up the issue of lifetime, I think it's just that we need to find the right word. I think
Yes.
we understand from where you're coming, and I think we're just reusing the same concept to talk about more like scheduling or time sharing the same resources across multiple trusted entities, for example, right?
Yeah.
So we just need to disambiguate that properly. Maybe I have a knife question if I can ask, and if you don't have anything else to add.
Well, I do have this entire section on the impact on remote attestation, but we can come back to it in a minute. So what's your question?
Yeah, so my question is that at a very high level, do we expect several different workload entities, identities to coexist within a single trust boundary? Or
Yes, I
is it
believe
our
so.
intent?
I
Okay.
believe so. And I believe it's captured. Yes, a workload may have multiple distinct credentials issued to it. That's covered right here.
Um,
And
what
these are just examples. Purposes inbound, about internal. But it may be that one workload gets different credentials to access different backend stores.
Okay, got it.
Yeah.
Okay.
All right. So now, so this one is the next section is, these are all requirements, of course, but they are requirements that need to be met by the attestation SIG. So I'm, we can keep them here, or we can throw them again back over the wall to the attestation SIG, but these are still requirements. And I'm going to ask in the attestation SIG today that somebody from that SIG, work with us or suggest a way to do it jointly. But let's just go over them real quick, just to see if I can get any feedback. So, remote attestation needs to somehow help me with workload credential issuance. And today they don't. Like RATS does not talk about identity, does not talk about identity providers, and that's a problem. So that's the kind of a call to the attestation SIG to help create these specifications. The second one is provenance, using provenance term again. how to bind provenance into the issued credentials, and what's the role of remote attestation in that. Again, that's a mechanism question. I don't have an answer. I'm just raising a question. So the verifier decided to issue certain attestation results based on a set of decisions. How is that captured in the credentials that will be issued to the workload? Don't know. Have to ask. Workloads ought to be able to both generate and certify their own keys or obtain credentials from secret key source. So we need both models. I prefer the one where the workload gets its own keys, because then they are shielded by confidential computing by T from disclosure, versus the credentials that are injected into the workload from the outside. Who knows, where those where else those credentials have been. And but we're not in a place to mandate that a workload must create and certify its own keys. We can say it's preferable, but remote attestation in both of those cases has to be precisely defined by the supporter. I believe that we just need to ensure that remote attestation can help me with both. All right, remote attestation based workload credential issuance, and I'm trying to capitalize terms that we have defined as terms of art. Has to be supported on a wide variety of computing platforms and mechanisms, including serverless managed workloads, well, strictly fault computing hardware based. So this one is kind of captured by the fact that in the core set of requirements that we talk about short, long lived, but we can we can say it's a requirement here too, but reference architecture may talk about provisioning versus operational mode or whatever other mechanism we decide on. Compound or composite, we call them composite. So again, this duplicates which one is it about composite?
Right.
Yeah. Where am I? Okay. So this we may need to strike it down because it's already maybe consider removing. But remote attestation needs to help anyway. So it is a requirement, and there is a remote attestation angle to it. Credential issuance, reissuance, and revocation may need to be optimized differently for short-lived and long-lived workloads. I think this is not a remote attestation. This is like a verifier will not have a decision to make here. So I'm actually going to strike this, if that's okay.
I would strike it, or I would just move it up to point number 5, where we're covering lifespan at this time. I don't think it's going to make a big difference either way.
Just to kill it. This the composition has a verifier angle to it, but credential lifetime does not. Okay, governance. Workload themselves must follow governance patterns being specified. Okay. I think this needs to be removed. That's like self-evident. We're not gonna. Okay, so that's it. That's the list. So going back to, there are some notes and clarifications like we did with the charter, basically explaining sort of the reasons for certain decisions being made. All right. So let me bring your attention to a couple of other things. So there is the reference architecture doc. I'm going to bring it over to this screen. Okay, it's early draft. Let me drop a link to the chat. Yeah, okay. All right. So this reference architecture is very much a draft document. So there is a lot of just early contact here. You can see my lorem ipsums everywhere because we don't know yet. But here I already said something about short-lived workloads. Yeah, so already, how I said, there is an operations mode and there is a provisioning mode. And I'm just putting it here so we can have a discussion. There's section reverse proxies, claims about hosting environment, because a remote attestation is going to tell you anything trustworthy necessarily about the hosting environment because it's outside the what the T is attesting, and yet we need to have a reference architecture around how to combine both claims. Very important for compliance because laws are still often geography based. Hosting environment matters. Talked about workload migrations. Again, we don't know what to say yet. And then there's the key questions to answer. So this is a somewhat parallel to the requirements. So we already talked about reverse proxies, short-lived workloads, provenance, composite workloads, claims about hosting environment, workload migrations, upgrades. Anyway, anything you feel the reference architecture needs to answer, feel free to just add it to this list, and eventually it'll make it. Like we'll produce answers to these questions. So again, that's this is the seed of that document. And lastly, before we break, it is not possible to do this work without understanding things like SPIFFE architecture and without understanding things like the WIMSI architecture, because we seek to be compatible with them. We need to understand what the gaps are. Towards that end, in our trustworthy workload into Google folder, there is this gap analysis folder. Again, dropping the link in the chat. So there is a document on where are the gaps between what confidential computing can deliver and what SPIFFE does. And this talks about, for instance, like node attestation isn't really going to work for us. WIMSI gap analysis is, this is what WIMSI does versus what we're hoping to accomplish. We need to understand what the gaps are. And then we'll go and address the gaps. So please read and contribute. In total, needs a gap analysis. So I'm hoping somebody would do that. And I'm waiting for others to join us for contributing. And one of the goals for this working group, I believe, is in order for us to work with WIMSI, IETF speaks in one language only, and that's informational drafts in RFCs. So I would like us to submit an informational draft to the Madrid IETF that I can then fly to Spain and present in July. And then we need to collectively decide what goes into that thing, and if it's just one document or multiple, and what exactly we're going to say, such that it receives a proper hearing. All right, with that, I don't have anything else today. I will probably, if you want to stick around, I'm not going to terminate this meeting. I'm just going to wait until the top of the hour to see if some people got confused by the time zone, and we can, I don't have a meeting at the top of the hour, so I'll do that.
Just a quick question on the IETF. When does that need to be submitted by?
Oh, I don't know. Good question. But probably by June.
Okay.
We still have a couple of months. But I'm going to be talking to Hannes because he is an IETF old hand, and others at in the working group who have IETF experience, and I will ask them for guidance. Okay, I'm gonna go silent for a couple of minutes, and I'll wait for the top of the hour to see who else wants to join. So we are adjourned until
Thank
then.
you.
That's good. Thank
Nice
you.
meeting you. Bye.
Sweet. Bye. Hi, Yogesh.
Huh. Hi, Mark.
So I knew this would happen because
Oh,
of the time shift. Because
yes, yes. This is the problem with the time shift. Not many Europeans remember. I had to explicitly remember to join early because the normal time is 3 o'clock our time. But now
yeah,
till
no. So
next
we
week.
just had our meeting. So I'm like an
Yeah.
hour in now, but I stayed online just to see if more
Oh, is
people
it?
would join.
But
This
it,
is
I
this is
thought initially you had 3 o'clock, right?
no. This is
Ah,
now. You are an hour late, but that's why I left this hour so
oh,
we can repeat what we just did. It was only a couple of people who joined. Um,
okay.
so that's how I knew there'll be more coming. So I'm just gonna give 3 more minutes,
Hmm.
and we can hopefully do it
Maybe,
again.
yeah. Maybe you can
And
update us with what you did discussed and was there any meaningful stuff you did discuss in the meeting?
which meeting? Oh, the one. No, we're just gonna do it again. So we went through the requirements document.
Okay.
And I presented this seed very early reference architecture document, and we talked about what needs to be done after this. Um,
So you
so,
have some place to put the reference architecture. I recollect you have a Google.
yeah. We have our Google Docs. If you look in the chat of the meeting, all the links are there.
Okay. What is the PST time, final PST time you are scheduling for this meeting? What time?
6 a.m. Pacific.
Okay, so it will always be 6 a.m. Pacific.
Until we choose to reschedule it. And also, it's on the Confidential Computing Consortium website. You can just go there, and the meetings are in the calendar.
Tuesday, 6 a.m. PST.
Mhm.
Okay. Workload identity. Okay, so 7 a.m. would be 3. But
Yeah.
again, next week, 6 will be 2 o'clock. Right now, it
Mm,
was 1 o'clock. Okay. Okay.
yeah.
2 p.m.
So
UK will be the. So this will be from next week. 2 o'clock is the right time. Today I
I
joined at
guess
2
so.
o'clock, but I missed it by 1 hour. Okay, got you.
Yeah, something like that.
Hmm.
Okay. So let me share my screen, and
Yeah,
like if nobody else joins, then it will be very, very quick because I'll just show you a couple of things that
sure.
I
That would
want
be
done.
awesome. Yeah, thank you.
Yeah, and then
Because I really want to contribute and I want to kind of work with you
yeah,
on this. I am
I
trying my
hear
best,
you.
but somehow I'm missing the meetings all the time. So,
That's okay. It's growing pains. It's gonna get resolved.
yeah.
I'm just trying to figure out
Do you
which
want me
one
to
to
share?
share. Oh, no, I got this.
No.
Um, so, all right. So this is the requirements document,
Mhm.
and this is the one that I originally wrote for the attestation SIG,
Yeah,
and I basically brought it back. I removed things that are already defined in the charter,
yeah.
cleaned it up a little bit to make the terminology consistent, but
Mhm.
ultimately there is a set of so far 9 requirements that the workload identity reference architecture must address. And it talks about, like, this is just portability and standards compliance. This one is, your workloads could live in different places, IoT, personal devices, public cloud, or on premises. Again, if anything's missing, you can add.
Yeah, I will
Then
need to
the
review it again.
workloads,
Yeah,
yeah, the workloads can have a variety of shapes. So here we're talking about confidential machines, confidential containers. Should I say confidential containers? Should I say confidential containers and Kubernetes pods, enclaves, serverless computing, on-premises services such as database services, queuing services, etc. And then managed services are SaaS products that, it's not a single database or queuing service. So it's just a thing
yeah,
that a SaaS vendor might offer. It also
yeah,
needs an identity so you can know to trust it. And then they can be standalone or composite. There is a
yeah.
whole issue around the composite parts of a workload may actually have different lifetimes. They may come and go. So sharing the
Mm,
lifetime is probably not the right way to see it. So we kind of raised an
yeah.
issue at the end of the document talking about.
So you're saying that a composition can change. So right now my composite workload has three sub workloads or whatever you want to call it, a child
Yeah,
workload in the
yeah,
so one of them can go while the two remains. So
yeah.
the
Like
composition can
agentic
change
AI is the
basically.
one that's like, you know, like things will come and go. You fire up agents, you shut down agents, etc.
Yeah.
All right. So that's, we just need to figure out how to say that and how to
Hmm.
think about it. So right now it's just an issue. It's an issue for
Mhm.
discussion. We'll have to come up with something.
Yeah.
And then we're talking about a workload can have multiple distinct credentials. So it's not a one-to-one mapping between the workload and credentials. And in fact, I may have one that I present when somebody authenticates to me, but it may be in different credential and a different identity as a result when I go identify to a backend service. And maybe components of a workload in the composite workload may have distinct identities for talking to each other, or etc. So this is where I'm basically saying you may have different credentials. That's completely supported.
Hmm. So the credential issuer is uh, the so which is permanent? The workload identifier is permanent or the credential is permanent in our model? I keep getting
So
confused.
credentials are ephemeral. Credentials
Mm.
lack permanence. They have a certain lifetime, and then they may get revoked. You may get new ones, but the identity needs to stable because the relying party, even if you present multiple identities, they're still stable because the relying parties need to form authorization policies around them.
So a workload has an identity or a workload has a credential?
A workload has an identity and it has a credential, and it's in the SIG charter. It actually explains it. So basically, a credential is what communicates the identity to a relying party. Credential proves the identity, right? And identity, again, there's all these definitions are in the charter. You can read over them. But
Mm-hmm.
an identity is a stable construct,
Mm-hmm.
certainly from the relying party perspective, and credential is an ephemeral construct because it has a lifetime.
So if workload, once the workload is finished, its identity is also finished.
Well, it's if the workload starts up again and it's the same workload, it's going to have the same identity.
Oh, okay. What would define as the same workload? Because it has died now after 1 hour, 1 day, 2 days, 2 years, it
Because
come up.
it's the same,
That's the tricky
effectively, it's
thing.
the same workload identity. If it's like payroll application, it's an identity, right? And then 3 years from now, we'll still have the payroll application. It will still access the payroll database. The composition may change, but its
Mm,
identity is the same.
okay. I'm thinking on that, but maybe you're right.
Well, because the relying party, the database needs to know the payroll application that's accessing me. That's not going to change just because somebody deployed a patch or because they decided to re-architect it.
But if the measurements change, okay, its attestation properties can change, but because you want to identify it as a payroll application, you don't want to change its identity. You want to
Yeah,
remember it as a payroll
right.
application. Okay.
Yeah, yeah, yeah. So
Mm,
all of that is in the charter. So we're not going to repeat that here.
yeah.
So here we're talking about lifetime of credentials, right? So depending on whether your workload is short-lived or long-lived. Basically, if you issue brand new credentials to every short-lived workload, you will quickly blow out your verifier, your IDP. It's simply not scalable. So in the reference architecture, I added a proposal that a workload can be started in one of two modes. And this is in the reference architecture doc, which
Mhm.
again, the link is in the chat. And here basically saying, if a workload is short-lived, maybe it starts in a provisioning mode where it goes, obtains credentials, and then seals them to the platform. And then when the same workload starts, or additional workloads of the same type start on the same instance of hardware, then they can just unseal their credentials and proceed. And it's a suggestion. Maybe there's a better suggestion, but that's the one that I'm putting in for now. But
Okay.
that's how we address short versus long-lived lifetimes of a workload.
Okay. These are the same requirements which we did on the
Yeah,
meeting repo, right? You have just effectively kind of moved from there to here, right?
yeah, yeah,
Or
yeah.
you have added any new requirements to that repo?
Not really, not really. No. Then we talk
Okay.
about governance.
Yeah.
This is just basically saying, look, you need to worry about the histories of decisions made to issue identity and credentials. And you need to be able to identify, isolate, remedy vulnerable workloads. Additional um, um, requirements. I'm basically incorporating whatever we do in the GRC SIG around workload identity governance by reference. So that I'm just saying, like, we'll figure it out, but I'm not gonna capture all of this here because it's subject of this other SIG. And then workload identity must coexist in a predictable manner with regular data center maintenance operations, such as workload migrations. A couple of statements to that.
This is we
None
have
of this is
discussed
cast in
already.
stone. Like, feel
Yeah.
free to review, add your own
Yeah.
content. This is like basically the next step of the G charter is that we define precisely all our requirements so that we know exactly what problems we're solving. And then from there, the reference architecture is going to address all the requirements. And then we're talking about the reverse proxies. Right, so we basically need to understand if there is a series of reverse proxies between the client and the server, what identities get presented at each hop. We need to figure that out.
Yeah.
So that's the first 9. And again, if you think that this, I don't know if this is a complete list. Maybe there's something I missed about
possibly,
the requirements, but I'm not mentioning isolation, provenance, or binding because that's part of the charter. That's already been defined.
So the provenance of a workload, we are not keeping it as a requirement here. That a
Well,
workload.
because it's already the SIG charter already defined it, so it's in the reference architecture. We'll speak to it.
Yeah.
So look, in the reference architecture, there is a whole section down here, key questions to answer. This is we're gonna remove the section, of course, before the document is published because we'll answer all the questions. But this a whole collection of questions, and one of them will be provenance. We'll speak to that in here.
Yeah. Sure.
Okay.
And one question I wanted to ask you is, where does attestation fit in here then? Remote attestation.
So all of this is now remote attestation. And I do not know if there's a separate set of requirements or we should just push these requirements over to the attestation SIG, but they're all captured in here for now.
So these are workload specific attestations, so we should keep it in the workload identity.
They are attestation verifier requirements having to do with workload identity. Yes.
Yeah, attestation verify requirement, the remote attestation verify requirement coming up from the workload identity, right?
Yeah, yeah. So I mean, if necessary, I can go.
Yeah.
Like we can continue previous numbering. How about that?
Yeah,
right?
I'm okay with that. I'm really okay with that for now, unless somebody objects and we have a kind of a group brainstorm.
Yeah.
There must
so these
be
are verifier specific. This one talks about mechanisms for composite workloads being attested. So this,
yeah, I fully understand that part. So there is a CPU, GPU, and all those kind of composite attester.
Yeah, or maybe you run, an entire service that has runs on multiple devices, load balancers, and queues, and database stores. Maybe it has an identity of its own. So
yeah, but the service may have an identity, but service may be comprised of multiple workloads, some running on CPU, some on GPU, some on
exactly. So we need to figure that out. But certainly these 4 having they are attestation SIG specific requirements. Anyway, so that's the list. Please feel free to review. We're not gonna take up a whole hour, just you and I. But reference architecture. If there's any questions you want to put in, or you want to start entering content for answering some
I'm
of these
happy
questions.
To enter. Yeah. Sure.
Please feel free to go. Just keep sure it's in the you're in the suggested mode, so we know who's adding what.
Oh, okay. So I add my some initial or something, and then I add the text.
No. Just click here to suggesting mode.
Okay.
Yeah, and then it's like so you know here that I added this. See, Mark Novak added, and then your guest added, whatever.
Oh, okay, fine. Yeah. Makes sense.
So just feel free to edit it. We'll just keep suggestion mode on. So the other thing I wanted to mention is one of the goals for us, like short-term goals. I would like to start working closely with Whimsy, and that requires speaking the language of the ITF, which is informational drafts. So I would like our working group to author an informational draft and submit it to Whimsy for the Madrid ITF.
Yes, so I can really help you with that, because I have done that in the past.
Fantastic. So I'll be, so we'll need to have a conversation in the SIG probably next week.
Yeah.
About what it is that we are doing in the in the IETF space. And of course, it needs to be based on our discussions, our requirements, but then it needs to be presented in a way that Whimsy is likely to adopt as opposed to reject.
Yes. Yes.
And
yes,
for that,
yes.
all of us need to be very, very familiar with the Whimsy architecture right now.
Yes, you are absolutely right. And I will be able to tell you that next ITF, I'm most likely to be there physically in the Whimsy group. So I'm happy to interact.
Yeah,
And in the
I will
past,
probably be there too.
yeah, I will be there in the past, like not this ITF because it was in Bangkok. Before that, another one was in, I think, Ireland. And I had a detailed discussion with the Whimsy guys. So they all know me very well. Peter and all those know me very well. So it is easy to work with them. They are good guys.
Yeah.
We just need to be a bit more familiar with their architecture and then align with them so that they don't reject our work, but our work adds as an addendum to their work. So
Right. So let's figure out. And like the thing is, I don't want to keep this wait with this conversation until June because the ITF is in July. I'd like to make sure that we're on the radar, sufficiently early, but also with sufficiently high quality.
Sufficient meet. We need to add a meet in April and May.
Yeah.
And then present sometime in June, so that we have good 8 weeks of time to polish this, improve this, brainstorm it within our group.
I haven't been active in the ATF. I've been sort of attending meetings, never submitted a draft. So yes, your help is very much appreciated in getting that done. All right.
So
that's all
I
I
will
have
see
for
what
today.
repo should we do because unless we can't do it in their repo, unless they accept that we should, so we need to first present outside, and then once they accept it, then our work will go into their repo.
And
so
also, I think what we can start doing immediately is reviewing the Whimsy architecture and all the drafts in there, and perhaps starting raising issues in their repo now with issues that relate to confidential computing. So again, I don't want to do it as myself. I want us to decide what issues to raise and how to interact
but
with
how
them
that will
as a
help,
group.
Mark, how raising issues on them will help because they will end up solving our problem. We want to kind of create our presence there, right? So do you think we should
This is
issues?
why I think we should discuss how we engage. I don't have ready-made answers just yet.
Yes, I think let me think about it. Maybe we capture our requirements, we start our work, we prepare our draft, and then we say that, hey, then we go and raise issues and link our work to the issues to say that this issue is a gap. Here is this document which addresses this gap. This issue is a gap. Here is a document this addresses this gap, so that they understand that there is an issue and a solution as well. Otherwise they will start working on a solution which is doesn't we don't want them to fix the problem of confidential computing. We want us to provide a solution to that problem, right?
You're absolutely correct.
Yeah.
Okay, so that's all I have. So I'm gonna wrap up now. And I guess I'll see you next Tuesday at the
this time, same time next
at
Tuesday.
whatever time the calendar says at the
And you
All
need
right.
to if you can please post these two in the we should actively start using the Slack channel also in ITF, the TWI channel. So if you can please post these two links in the
to
TWI, it will
Slack.
remain as a in the Slack. Are you using this confidential
I
computing trusted workload identity Slack channel or not?
I haven't yet, but I will now that you
We should
mentioned
start
it.
encourage using it because you are there, Matt, Mike, Mohammed, Usama, me, we are all there. So
Okay,
yeah.
sounds good. I'll do that.
Yeah.
All
And
right.
then you want me to start kind of, okay, I will think I can produce a repo because I have produced draft using my repository, and then we can move it because CCC hasn't given us a GitHub repo, right? For now, yet.
Oh no, there is a GitHub repo. That's the one you created. That I think that can
Yes.
work. But yeah, they haven't merged my pull request yet with the charter.
Okay.
So that's okay. They
So
that will happen soon enough, and then we'll have our own mailing list and everything. But you can start anywhere. We can then move it around. But the repo you created is perfectly valid for this.
okay, my own repo which I shared with you, right?
Yeah, but like for the reference architecture and requirements, we're still working in the Google Docs.
Yeah. That's absolutely
Yeah.
fine. But we need to create an ITF draft, right?
We will need to create an ITF draft. I do not know what it's going to say yet, but I know I would like to start presenting our thinking, because the way we did it last time with the presentation, that did not land. They're like, you're not speaking our language. You are working on this from the outside. So now that was the sort of the hostility, because
Yeah.
they want to preserve their method, their way of doing things.
Terminology.
I do not have a problem with doing it their way. It's you know it's fine. Let's
Yeah.
just figure out the best way to do it.
Okay. So I was going to ask you, but because you were running out of time, that how was the ITF feedback? Because I didn't attend the session, but I saw the recording, but recording doesn't
Well,
give
if
you
you
the vibe.
saw
Yeah.
the email I sent after ATF, I summarized it pretty accurately, so you can just look over that.
Okay, I will. Yeah.
Yeah. All right.
Okay. Thank you so much for
I will.
staying and spending
Oh,
some
yeah.
few minutes. We need to
All
work
right.
together, and I will help you as much as I can. Yeah.
I appreciate it. Okay. Thank you, Yogesh.
Thank you.
Take
Cheers. Bye.
care. Bye-bye.